Today we are going to represent the numbers of the form root x on the number line, which is type 3 number line. Let us take the first example. Let us represent under the root 3.5 on the number line. So for this, first of all, draw a number line. On this number line, take any point A. Now open the compass equal to 3.5 centimeter. We have to take the same measure which is under the root. Open the compass equal to 3.5 centimeter and draw an arc from A which meets it at point B. That is, this distance AB should be 3.5 centimeter. Then keep the tip of the compass at B, open the compass 1 centimeter and from B draw an arc which measures 1 centimeter to get the point C. So AB should be 3.5 centimeter and BC should be 1 centimeter. Now you must be knowing that how to draw the perpendicular bisector of a given line segment. Draw the perpendicular bisector of the line segment AC. Let us recall the steps. What we do? We open the compass more than half of AC. From A, I will draw an arc above and below. Same way from C, I cut those previous arcs and joining them, I will get the perpendicular bisector of AC. The perpendicular bisector of AC meets it at point O. So this point is point O. Now take center O and radius OA or OC. Okay, with center O and radius OA or OC, draw a semicircle. After drawing the semicircle, at point B, draw a perpendicular with the help of a compass. The perpendicular meets this semicircle at point D. Now, this length BD is square root 3.5. So, open the compass equal to BD and from point B, draw an arc which meets the number line at point, say, P. So this point P represents root 3.5 centimeters on the number line. I told you that this BD is root 3.5. I'll explain you that why it is root 3.5 in the justification. For justification, we have to join O point to D. So join OD for the justification. Let AB is equal to X. Let AB is equal to X. Then what about AC? AC is, this is X and this is 1 unit. So AC is X plus 1. Now you can see here that OA, OC and OD, each one of them is a radius of this circle. So OA as well as OC and OD, each one of them is X plus 1 upon 2, as AC is the diameter of this circle. Now if I want OB, then the measure of OB will be, how I can get it? From OC I will subtract BC. So OB is OC minus BC. OC we have just calculated, it is X plus 1 upon 2 minus BC. Now BC is 1 unit. Solve it. So this is X plus 1 minus 2 upon 2, which is x minus 1 upon 2. Now apply Pythagoras theorem in triangle OBD. If you apply Pythagoras theorem, then we have OB square plus BD square is equal to OD square. We want to calculate this value of BD, so let us keep it on LHS and let us put the values of OD square and OB square in the next step. From here you can see OD is x plus 1 upon 2, x plus 1 upon 2 whole square, and OB we have just calculated x minus 1 upon 2, so this is minus x minus 1 upon 2 whole square. For further calculations, I can apply the identity a square minus b square is a plus b and a minus b. This sign will get changed. So this is a plus b. 2 I can take common also. So on simplifying this, here what you will get? You will get 2x upon 2, that is x. And after simplifying this, you will get only 1. So it means BD square is x, which further means that BD is root x. So using Pythagoras theorem, we can prove that this length BD is equal to root x, where x is any real number. Now students, let's move on to the most important topic of chapter 1, that is rationalization. From the name itself it's clear, rationalization means making something irrational into rational. So it is a method by which we can convert the irrational, like let me take the first example, it is 1 by root 2. So using rationalization, the denominator of the expression can be converted from an irrational number into a rational number. It is specifically for denominator. So let me explain this first example, 1 by root 2. Here it's a monomial only. So what we are going to do, multiply the numerator and denominator with this same number. So when you are doing this, this is equal to root 2 upon root 2 multiplied by root 2. And we know very well, root 2 into root 2 is 2. So this is root 2 upon 2. Now you can see that it's a rational number. So rationalization is a process or method by which the irrational denominator of an expression is converted into a rational one. Let us take one more example. Say 21 upon root 7. So what we should do? We should multiply both numerator as well as denominator by root 7. This number is known as the rationalizing factor for rationalization. When I multiply 21 into root 7, so 21 root 7 in the numerator, in the denominator it is root 7 multiplied by root 7, which is 7. Now the denominator has turned rational and we can further simplify it. I can cancel this 21 by 7, I can divide it. So this is 3 root 7. So here the denominator is 1, which is already rational. Now let us take an example in which the denominator is a binomial. Say it is 1 upon 2 plus root 3. Here we have a binomial in the denominator. So in such cases, we multiply the numerator and denominator by 2 minus root 3. 2 minus root 3. It means we have to take the opposite sign of this sign. If we have plus here, we will take minus, and if we have minus here, we will multiply, we will take positive sign in both numerator and denominator. So if it is 2 plus root 3, then the rationalizing factor is 2 minus root 3. Let us multiply it now. The numerator is 2 minus root 3 and the denominator is 2 plus root 3 multiply by 2 minus root 3. In the denominator you can see that it's an identity. I can use this identity that a plus b into a minus b is a square minus b square. So let us use this identity in the denominator. So a here is 2. So 2 square minus root 3 square. On solving it gives you 2 minus root 3 upon 2 square is 4. Root 3 square is 3. So finally the answer is 2 minus root 3 upon 1. So the irrational denominator has been converted into a rational one. Let's take the next example, children. This is 5 upon root 3 minus root 5. So here we will multiply the numerator and denominator by root 3 plus root 5. That is the sign which is opposite to this sign. So root 3 plus root 5, denominator also root 3 plus root 5. Let us simplify it. Keep this 5 outside and let us write it in the bracket. In the denominator, again this is a minus b and this is a plus b. So I can use the same identity again. A minus b, a plus b is a square minus b square. Let us write the numerator again. Root 3 plus root 5 and in the denominator I have root 3 square minus root 5 square. Let us move on to the next step. Numerator is same and in the denominator we have root 3 square is 3 minus root 5 square is 5. Now this is 5 root 3 plus root 5 upon, see 5 is bigger, so here I will get minus 2 and in the standard form we should bring this minus sign in the numerator. So the final answer is 5 upon 2 minus 5 upon 2 under the root 3 plus root 5. So here the denominator is 2, which is a rational number. Let us take one more example. In this example, we have 1 upon 7 plus 3 root 2. Here the rationalizing factor is 7 minus 3 root 2. So multiply the numerator as well as denominator by 7 minus 3 root 2. In the next step, numerator is same, 7 minus 3 root 2, and in the denominator we have 7 plus 3 root 2 multiply by 7 minus 3 root 2. Again we can apply the identity for a plus b, a minus b, that is a square minus b square. Whenever you use an identity, so you are supposed to write it. Here, let us apply the identity. This is a square minus b square. A square minus b square. So let us simplify it further. Numerator is same. Oh, children, this is 2, not 3. So let us make it 2. 3 root 2. So 7 square is 49 minus. For this, what you are supposed to do? 3 square is 9 and root 2 square is 2. So we have to multiply both of them. 3 square 9 and root 2 square is 2. So this becomes 7 minus 3 root 2 upon 49 minus 18, which is equal to 7 minus 3 root 2 upon, what is left? We are left with 9 minus 8, 1, 4 minus 1, 3. So this is the final answer, and see, our denominator has become a rational number. Now let us take the next example. Here we have two terms in this expression. Now let's take this example in which we have two terms to be simplified by rationalization. Here, let us take the rationalizing factor of first term, 4 plus root 5 upon 4 minus root 5. So here we will multiply the numerator and denominator by 4 plus root 5. We have to take the sign opposite to this minus sign. 4 plus root 5. Similarly, for the second term also, we have to take the rationalizing factor, which is different. Here we have a plus sign, so we will take negative sign here. So we have to rationalize it by 4 minus root 5. 4 minus root 5. Now this is 4 plus root 5, 4 plus root 5. 4 plus root 5 whole square. And in the denominator, same way, use the identity a square minus b square plus. Here you can see we have 4 minus root 5 whole square because it's 2 times, and in the denominator you can apply a square minus b square. In the numerator also you can see we have a plus b whole square, whose identity is a square plus b square plus 2ab. 2ab. And in the denominator, it has become 16 minus 5. Similarly, we will use the identity a minus b whole square in the second term. Let us keep it in the separate bracket, and now let us start with the second term. So, a minus b whole square is a square plus b square minus 2ab. And in the denominator, we have 4 square is 16 minus 5. So we have used all three identities in this question. So mention them separately on the right hand side. I am not writing here because of lack of space, but you have to mention each identity whenever you use it. Now children, let us do the next step. Let us simplify it. 4 square 16 plus 5 plus 8 root 5 divided by 16 minus 5 is 11. And the second term is plus 16 plus 5 minus 8 root 5 divided by 11. 16 plus 5 is 21 plus 8 root 5 upon 11. Similarly, this is 21 minus 8 root 5 upon 11. Now, let us combine these two expressions by taking LCM. LCM of these two expressions is 11. So, numerator will be 21 plus 8 root 5 plus 21 minus 8 root 5. We have one positive, one negative term, so let us cancel it. And on adding these two, I get 42 upon 11, which is the final answer. What you can do, children, you can simplify this first expression separately and you get this answer. Then in the second step, you can separately rationalize it, and in the end you can add them. You can combine these two steps. That is, you can do this question in 2 steps also. So finally 11 is a rational number and the whole expression is rationalized. As I told you that rationalization is a very important topic, children. So it has many applications. So one of the type of questions is this, in which we are given that 3 plus root 2 upon 3 minus root 2 is equal to a plus b root 2, and the question is find the values of a and b. For this question also, what we are supposed to do, we have to rationalize the left hand side of this equation. So let us rationalize LHS, which is 3 plus root 2 upon 3 minus root 2. Multiply the numerator and denominator by 3 plus root 2. That is the sign which is opposite of this. 3 plus root 2. Now the numerator is an identity 3 plus root 2 whole square. That is a plus b whole square. And in the denominator we have a square minus b square. Whenever you rationalize in the denominator, you will get this identity a plus b, a minus b, which is a square minus b square. Here in the numerator, this is a plus b whole square. So let's apply the identity a square plus b square plus 2ab. And in the denominator we have 9 minus 2. So let us simplify it. This is 9 plus 2 plus 6 root 2 divided by 7, which is further equal to 11 plus 6 root 2 upon 7. Now it is rationalized. In the next step, we have to compare it with the right hand side to get the values of a and b. So now we have 11 plus 6 root 2 upon 7 is equal to a plus b root 2. Now I can separate it like this. 11 by 7 plus 6 by 7 root 2, which is equal to a plus b root 2. Now we have to compare both sides, that is LHS and RHS. On comparing, just see the value of a is this value, that is a is 11 upon 7, and value of b is the coefficient of root 2. This is the coefficient of root 2. So the value of b is 6 upon 7. Hence, using rationalization, we can get the values of a and b like this.